What I have here is the cheapest USB charger I have ever seen in my entire life. I ordered this off of AliExpress and it cost me a whopping 52 pence with free shipping. 52 pence with free shipping. I genuinely don't believe that. I don't know how they managed to make it so cheap. What is inside this thing actually scares me because it feels ridiculously light. I might actually get a scale and weigh that in a second to try and work out how light this thing actually is, because this feels like there's nothing inside it. Yeah, we're gonna have a look at it today. Now I have the stuff to test it properly, and we're gonna have to see what it's like on the inside. I'll just cut the sort of give you the full unboxing. I thought I'd leave the plastic on, so I'll just slip that. See if we can try to peel off the sort of outer shielding and have a look, see will it focus on the writing enough for you to read it. We have model number E8680, so writing this is tiny. Input voltage is 100 volts to 140 volts, 50 Hz or 60 Hz. Output is 5 volts DC at 2 amps, we'll test that in a second. Date of manufacture potentially is 2017 and made in China. My Russian is not good, so I'm not sure entirely what that date there is. I might try and get a closer up picture of that so you can have a look at it. It's marked here CE mark. CE, Chinese export probably. Double insulated again. It should be if it's compliant, but I doubt it probably will be. We'll test that. We'll take the transformer inside apart and see if it actually is double insulated or not. And that is the only markings on this thing. This will be interesting. One moment while I'm going to get a scale and I'm going to go and see if I can find the adapter to plug this in, because I don't have one. Worst case scenario, I can bodge something up, but ideally I would use an adapter, so one moment please. Okay, so I'm back with the scales. I haven't actually got my adapter yet, but I just thought I would show you this because it's pretty ridiculous. So here I have an Alcatel branded, it's just a random 1 amp power brick I had lying around. Stick that on the scales, 44 grams. This here is my charger that I actually use for my phone. It is a Tiger Power branded one that I bought from CPC. It is 48 grams. And then we have the AliExpress special, 18 grams, or 20 grams, 18 grams. This very clearly does not have what is supposed to inside it. I'm getting kind of a combination of scared and curious. Let's see. Is this the correct adapter? No, it's not, but it is an adapter, and that's better than what I was going to do. Anyway, I've managed to find something that will kind of fit. This is an EU to UK adapter, except it's designed for taking a plug like this, not one of these. So it only kind of fits in, but anyway, that's beside the point. I'm going to turn it on now, and we'll see if it violently explodes. No smoke. This is a good sign. I could have put this on a thing to measure how much current was drawing at the mains, but I'm not going to. Now, I plug my tester in. 4.5 volts. Okay, that's actually really quite 4.52 volt. Okay, this is really quite high. This is much higher than it's supposed to be. Usually they're fairly bang on the nose, 5 volt, maybe 5.2 volt. 5.5 volt, I can't by God, it's going up more. 5.56. I can't remember what the actual USB standard is, but I'm pretty sure that that's already exceeded it. Oh, and it's power cycling. What's going on? Which way up does this have to go? Oh dear, that's what it's. No, I don't. There we go. I'm going to start drawing some current. This again is rated supposedly for 2 amps. Oh my god. I am drawing 200 milliamps. 200 milliamps, and the voltage has already dropped off to 4.69. You probably, I don't know, can you read these numbers? There we go. 4.69 volts. And then look, as I back it off to 0, the voltage way overshoots up to like 5.6 volts. Let's see if we can actually draw 2 amps out of this and what the voltage goes down to. Okay, so we're at 4 volts. Let's turn this back. There we go, 4 volts. And I'm drawing 350 milliamps. And then, oh my god, this thing is a piece of shit. It can't even supply 500 3.5 volts drawing 500 milliamps. And the tester is now so dim I can't actually read it. Drawing only just over 600 milliamps. My god. I was going to say let's leave this thing on under load for a few hours and see how hot it gets, but it's not going to bloody get hot because it's only supplying like 300 milliamps at 3 volts. That's total junk. This thing won't charge shit. Right. That's absolutely horrific. Yeah. To my not shock at all, this is a piece of shit. Let's open it. So I figured before we destroy it, actually, we should do some testing on it because I have big boxes that do testing. So let's use big boxes because I don't get to play with them very much. I have it connected here to the thing. There we go. Then the output of the USB power supply is connected back to the earth clamp on this. I've got the box here set for 250 volt insulation test. Let's run that. It's gonna sustain it for 5 seconds. Oh, and it passes. Okay, I'm gonna change the settings on this and we're gonna do another test after this, so 1 moment please. Okay, now I've got it set to what's called touch leakage testing, which is where it's going to measure how much current leaks back out the output from the mains. This should be as close to 0 as possible. The limit for the pat testing stuff that this tester is designed for is 0.5 milliamps over a 10-second duration. So I'm going to start that test and let's see what it outputs. It's going to run for a 10-second sustain, 0.02 milliamps. I am very surprised. I was expecting this thing to be completely shit. How the hell is this thing passing? My god. Okay, I have another couple of tests I want to do now because I'm getting rather annoyed that it keeps passing them. Okay, is it going to focus? I have it set for a 500 volt insulation test, which is the maximum voltage that you would usually test an appliance to. And we'll see if this is going to pass at this. If it does, then don't worry, I have much higher voltages we can test it at. So I'm going to run this. And clicky clicky click, it's going to sustain for 5 seconds. And bloody hell, it's passed again. Right, I need another box with a higher voltage. 1 moment. So I have here my old Mega tester. I've set it for a 1000 volt test, skipping all the stuff before that because we already did that on the other box. I have connected the power supply across. I've shorted both the input terminals and both the output terminals and then connected them to the output of the machine. These cables will be fine for this test, even though they probably aren't rated for 1000 volts. They're probably only rated for 800, but it doesn't matter. I think actually they might even be 600, yeah, it doesn't matter. They'll be fine for a short duration test, and even if the insulation did fail, it's not going to injure anything. So I'm going to press the test button and sustain it, and we have 1000 mega ohms, or just over 1000, or just under 1000, sorry. we have to multiply that by 2 because it's a 1000 volt test, so just under 2000 mega ohms. Again, the damn thing's passed. This just won't do. I have yet another tester which we will use after we've explored the internals of this, because that definitely will make it fail, I'm sure of it. So we're back to the stable but unfortunately not quite ideal camera angle. I am working on a better camera mount. It's going to have you looking down on my bench rather than sort of over my shoulder, but I haven't. It's going to require me to make some structural adjustments so that the bench doesn't collapse from the additional weight. It's already bending like a banana just from the test equipment, and I don't think it'll take all the extra camera crap attached to it, especially because I'm going to have to drill quite a large hole through the main supporting beam. Anyway, that's for future problems. One of my bloody testers. Anyway, one of the requirements for the British standards for, well, mains enclosures, anything with mains inside it, is that it must be only accessible with a tool. So a screwdriver or something else must be required to open it. And I see a gap here, so I want to see if I can open this without a tool. If I can, then it's failed the test already, it's non-compliant. And oh dear, what a shock. I finally got it to fail a test. Now, some pliers to pull the board out and have a look and see what's inside. Very old school. I see one transistor, the tiniest switching transformer I've ever seen in my life. Like, this is minute. Hold on, let me see if I get the camera to focus on it, because it's really quite cute. Come on, camera, bloody focus. I put my hand behind it. Is it going to focus? No, it's not going to focus. Okay, I'm going to have to mess with that in a second, see if I can get it to focus. Oh, and no SMD components either. Oh my god, and I see the separation. Is that the separation distance? I really hope that's not separation distance. Okay, I'm going to have to try and work out what the separation distance is, but I think it might be horrific. Absolutely ridiculous. I think it might be tiny. I'm going to see if I can sort of get the camera to focus on this board so you can have a closer look at it and see it in all of its glory. And I'll talk about the problems I see with it as well, because I already see problems. So, one moment please. Okay, so I've taken a picture. It's not of the big Clive standards, but I've taken a picture and blown up of the circuit board here so I can actually point to things you can see what I'm talking about. And I have reverse engineered the board. That's it. Talk about minimalist. I'm going to speak about this in a second. Just quickly going on here. Mains comes in here. That there is the rectification diode. That's a problem. It should be a full bridge rectifier, not a single diode. Admittedly, with something this tiny, it doesn't really matter. But when you have something big, or a lot of tiny things, all using half-wave rectifiers, it will sod up the grid transformers. They don't like it because they're only being loaded in half a cycle, but yeah, that's complex theory stuff. Only one transistor, it only has one switching transistor. It's using the inductor of the core to oscillate with. Again, I'll show you that in a second. Usually you'd have two transistors in a sort of oscillating thing, or a chip, but this one only has one transistor. A couple of diodes. These are noise suppression. The starter resistor here, what this does, it leaks a bit of current from the positive supply rail into the base of this transistor to turn it on slightly, to induce some current to flow through the primary winding of the transformer, and then that will induce current in the feedback winding, which will then turn this on more. Yeah, I'll show you that on the schematic. And it uses that to oscillate the feedback winding basically in the thing. There is no voltage regulation on the output. That's why it was so unstable, and that's why it was so high, was because there is no feedback on the voltage regulation. it's just using basically this transistor turning on and off, pulsing the core, and it kind of just chucks out whatever it'll chuck out. There isn't really any. Actually, one of these might be a Zener diode. Yeah, no, that probably. I will check that in a second when I'll dig out the meter to test that and I'll check that. I just thought, because I was just thinking, it's never going to turn off then. It's never going to turn off if it. Yeah, I'm going to have to explain this on the schematic, hold on. So, here, we have the same thing, rectifier, diode, smoothing capacitor. I have fuse, because I didn't take a picture on the bottom of the board, but if you look on the board here, I'll see if I can zoom in and post or something, but if I point, that is the fuse. There, you see that wiggly track? That's the fuse. But anyway, yes. So, rectifying diode, fuse, smoothing capacitor. This is the starter resistor I was talking about. And then it has this here, which is, I assume, some sort of noise protection. Here's the feedback winding. And then there are these two diodes here, which again I assumed were noise, like back EMF protection. But this one, now I think about it, might, in fact, actually... Oh, no, I see what's happening here. I'm being stupid. Talk about someone not thinking about the schematic before they press record. This is the feedback winding. This diode is rectifying that, and this is the buck regulation capacitor. This is probably a Zener diode, not an actual diode. I didn't think to test that. So I will check, and I will put a note, probably in some text somewhere here, and I'll say in the video again after I've done that, whether this actually is a Zener diode. I might even just show you me testing that. And then here on the secondary side, we have a whopping 3 components. We have a diode, which is, let me get my picture back, this diode, which is a 1 in 4 148, 1 in 4 148, which is only rated at like 150 milliamps, far from the 2 amps it states on the thing. The data pins are just shorted together, which would to communicate the rating of this device. And a 220 microfarad 10 volt smoothing capacitor on the output. That's it. That's literally all there's to this. Give me one moment while I just check some of these diodes to see if they're actually... I think this here might be a Zener diode, and I'm just being stupid. Give me 1 second while I test that. Okay, so you can see, I'm actually going to show you the testing because it's going to take a couple of seconds. This is my diode tester I made. This sticker on the side of it is basically saying, danger, don't touch the output probes because it will hurt a lot. 100 volts, this thing will output a good few milliamps, and that will not be a pleasant experience to contact it. So I'm going to do this, 0.8 volts, which is reasonable for a diode, and then we do that. Yeah, that was just me being a complete moron. This is, you see it says 6.7 volts there, this is a 6.7 volt Zener. Now the question is, no, I'm not going to re-record that whole section. I'm just going to say I'm being stupid, and that diode there is in fact a Zener, and I just wasn't thinking. Okay, now on to some high voltage toys. And if touching the output of the previous one would hurt, you do not want to even know what this would feel like. This will fail it. I guarantee this will make it fail. This is my high potential integrity tester, which I just built, and there will be a video that I built which may or may not come out before this. I don't know, probably will. If it did, I'll put a link in the description thingy. Yeah, this outputs 10,000 volts onto the leads here. So you see it's ready. I'm going to zoom you in on this board. I'm going to dim the lights when I fire it, because I suspect well no, I know we're going to get arcing. So I'm just going to move you down a bit, probably tilt you round, see if I can go down a bit more. There we go, nice and focused. I'm going to now reach round the camera and okay, it failed. There was 3 milliamps of leakage. Now we'll see if we can see any arcing on the back. Oh, surprisingly not. I definitely hear it though. Yeah, I definitely hear arcing. I wonder where it is. It's probably inside this transformer here. I'd guess it will have gone through that. Yeah. Okay, so now it has definitely failed an insulation test. I'm going to open this transformer and we're going to have a look inside. Okay, so I in fact did find the source of the arcing. You can probably see on the tape here, it burnt a big hole right through it. It was arcing from the feedback winding, which is on my schematic here, that one. It was arcing from the feedback winding to the secondary winding. And as I say, it had burnt right through this insulation here. You can see the big hole in it. So indeed it was arcing over inside the transformer. To be honest, I wouldn't expect any transformer to survive 10,000 volts being dumped directly across it, unless it was, well, designed to have 10,000 volts dumped across it. But still, it probably should have survived it more than an immediate breakdown. The capacitors that are usually used are rated for 8,000 volts. So I would expect that they'll take 10,000 volts across them. I don't know, I've never actually tested one, but maybe for a future video. Anyway, in conclusion, this thing is a piece of shit and it will burn your house down. Do not buy it. Even though it did actually pass most of the normal safety testing, the isolation distance on the bottom of the board is 1mm. This is connected directly to the mains, and that is connected directly to your phone. The gap between you and mains is that tiny gap there. Between, where's that I can point with? Between this track and that track. That is all that isolates you from mains. If it gets wet or carbon tracks or anything, and the mains gets to here, this track here connects directly to the USB port and will come directly out into your phone and potentially give you a serious electric shock, so just don't risk this kind of thing. I might try showing you a better one if I can find a good power supply I can destroy what a proper one actually does, because they're supposed to be way more complicated than this. This is one of the most minimalist designs I've seen. It's, yeah, not to be used, and the ratings that thing states on it are complete shit. Again, absolute bollocks. 2 amps, my eye. It would barely supply 200 milliamps, let alone 2 amps. So, like, failing to meet 10% of its rating. Again, I'm not surprised. That's usually how these things go. They say 2 amps on them and they won't supply anything even close to it. But, yeah, thank you so much for watching. This has been an interesting teardown here. Hopefully this video will be a bit shorter than the ones I've been making previously, build and restoration videos and stuff. Hopefully you enjoyed it. Do the YouTube things, liking, subscribing and such. And I will see you in the next one.